Welcome, everybody. We're going to be working on Unit 6 tonight, which covers Chapter 7 in our textbook. And the main topic is subqueries. If I were to summarize this in one phrase or sentence, I would say that a subquery is a way to add a query inside of a query to get more powerful results from your query, right? Um, and there's a lot of nuances to this, and there's not necessarily a better way or a right way to do it. Ultimately, when you're writing database code, if it pulls the right information, it's correct. And this is really kind of like, I think, a takeaway that students sometimes miss, that often you can write code, and this is not true of just databases, but in any programming language too. You can write code that can accomplish a task that is very different from somebody else's code, but still accomplishes the task. So sometimes, there are many ways to accomplish a subquery. And that's one of the things that kind of becomes confusing, because you might be looking for, well, what is the correct way? I get people that will say that. I'm like, well, it pulled the right information, right? It's correct. So then it's correct. If it's pulling the right information, it is correct. If you're looking for to get more technical about it, because this is very true of programming in general, if you're writing code that can accomplish the same effect that is shorter and more succinct, generally I'm going to say that might be more correct, right? But I think that applies really more so to traditional programming versus database work, because database processing happens in a much different way than regular program processing. For example, if I was writing a query that included a subquery, or I was intelligent enough to join my tables in advance, and I could just run the query on the joined tables, and the joined table approach might be more efficient, but that assumes that I had the forethought to think about it in advance. Now, if I compare this to a regular programming language where I might write one line of code that accomplishes a task compared to somebody else who had to write 10 lines of code to accomplish the same task, I'm going to say that my one line is better and more efficient and probably more correct and the preferred way to do it, especially if it operates more quickly, right? In a database, the complexity or the structure of a query does not necessarily make it operate more quickly. So that's why I say in database design, what is correct is relevant to the information you're trying to get, as opposed to how many lines of code it takes to get there. Right. So I hope you see that as kind of a logical thing. All right. What I'd like to do first is talk about some of the concepts from some of these website references that I have. We will look at the author's slideshow as well. That will be skimmed over very, very quickly, only to reinforce the materials I'm pulling from these other sites. I am actually going to start with the materials from the MySQL tutorial site. And um, part of like the content here is drawn directly from that site, because I think they did a very nice job of explaining it. And so I'm going to go ahead and click on this link here to take us to that tutorial site right now. And I think I already had it open, but okay. Second tab open. There we go. I'm also going to zoom in a little bit to hopefully lose some of the ads. Okay, there we go. I know that's obnoxiously large, but hey, it is what it is. All right, no ads at least. All right. So it says in this tutorial, you're going to learn to use subquery to write complex queries to understand the correlated subquery concept. And this is really kind of important to understand, that really, if you want to quantify this, I think of it as a query inside of a query, which helps me to come up with better, more qualified results. So if you want a little bit of review, and notice it here as they start to write about it, they want you to kind of basically remember and maybe review these other query operations, which we consider like basically the four basic ones, which is to select, to do insert, updates, or deletes. And of course, when you do any of these, you have statements like select, from, where, group by, having, or order by, for example, right? So all of those things are in play, right? And those we consider query basics. Um, so why would we basically use this? We use this in a lot of situations where we need to pull information from a set of data, but only under certain conditions. So that you can kind of start thinking about this. Well, that's kind of like a having clause, isn't it? Right. Yes, it is. Right. It's additional qualification. But notice what the kind of the difference is here. So I'm looking at this one example query, and they're selecting last and first name from a table called employees. Okay, that's pretty normal. But the condition is where the office code in this other query, and notice where this other query comes from. We're selecting office code from an office's table. So it's coming from another table. So this is to imply that whoever built this database didn't ever do any joins, right? So like if you did for example, an inner join, you might be able to join the two tables together and run the query. So one example that you'll see with this is that, oh, so I could either do it like this, or I could do a join and then run it on two tables at the same time. Yes, is the answer. Which is better? Well, it depends on how your brain thinks. If, and I think this is a good general rule, if the tables are linked together in meaningful ways and you're already running queries where you're doing joins, you just stick with doing it with joins, right? However, I would say like in a more maybe on the fly or ad hoc kind of approach where you don't have a join built, this is a good workaround. And it's not, you shouldn't think of it as a workaround. It's just a different technique for extracting the same information. So we're really running this other query that could stand alone all on its own, right? And we're placing that inside the condition. So in other words, we're going to pull the last and first name from employees if the office code works in this query. So we'll select the office code from this table, but only if it comes from USA, right? So it kind of saves us this rigmarole of doing a join and then including that condition in a different way. It is a little bit more verbose, right, than using a two table approach. But in some other ways, then you don't have to worry about like aliasing the tables and which table am I calling. And if you're not aliasing, saying like office code dot offices or offices dot office code or something like that. So it helps to really cut down on the syntax pretty significantly, I think. And in some ways, I think that people's brains kind of latch onto it a little bit better because it is a little more straight ahead. Right. So that's kind of my thought on it. All right. So they go in and they start talking about like how this is put together. And they use this little graphic, and I use this little graphic also, I think, or no, actually, I think I deleted it. I did have it originally in my posting. But we kind of think of these as outer query, inner query, or the main query and the subquery is another way to think of it. Terminology is not really important, but you can think of the subquery as the query happening inside the query. All right, so there's an example. I like this graphic because when they put it inside parentheses like that, you can kind of tell it's like, well, it's a bigger query, and then we got this other one inside of it. Okay, so that's the process, right? Okay, so this is an interesting tidbit. When executing the query, MySQL evaluates the subquery first and uses the results of the subquery for the outer query. Now, if you think about the logic of that, that makes sense because I would need to know this information first, like which office codes are for the offices in the USA before I can run this query. So it's not like doing this one and then running that one and then comparing and then removing. It's running the inner query first, and then it's running the outer query. That's from a processing step. That's what's going on. So here they start talking about putting a subquery basically inside the where statement. And that's kind of where we start out. So what is placed inside that subquery really depends on the information inside the table that you're trying to extract in the situation. Here's a really good example where they're not sure what the information is, right? So they're picking the largest payment amount from the payments table and they're setting that equal to amount. They don't know what the value is, right? Because you don't want to have to look through the table to find it. You run the query to find it and then you put that value there. I mean, what would be the alternative? Think about this. You could run the one I have highlighted, get the response, you have the number, and then it can drop that number into this other query and skip the subquery. But what this does is it dynamically grabs the information because maybe by the time you run your query, it's changed, right? Databases are alive, especially if you're working with live data. A new max could have come in by the time you've quoted the one query and you're running the second. So this is a fascinating way to think about it. All right. So they go through the process of showing. Now, what I do think is kind of cool, right? So I'm going to click through on the little try it tools, but this website also has a little try it tool, just like W3Schools has. And if you want to play with this, feel free. I'm not really going to go through the demonstrations on this, but if you're learning a concept and you want to reinforce things, or you, as often happens professionally, and I'm just giving you this tip, is you come to school, you learn all this stuff, and then you go out on the job and you're doing the work, and then you're like, oh shoot, I'm not sure how do I figure it out? Well, okay, there's tools like this online. Thank God for Google and and online references, really. And I say that sincerely because this is what happens as a pro. You cannot retain all this stuff, folks. Some of it you do, right, over time. And what's the stuff you retain? The stuff you do every day, all the time. But every once in a while, you'll hit upon things that you don't remember how to do. And when you have a resource like this available, it gives you the empowerment to find it on the fly as you need it. All right. So the other thing that they're kind of making a point of here is because often a subquery is based on a condition, and often it's based on a comparison. Like, so for example, we're looking to see if things are equal. We're looking to see if things are greater than, less than or equal to, greater than or equal to, etc. So any of those signs can be used in these expressions, right? So for example, this subquery, we're selecting the average amount from the payments table, but we want the amount in this query, for whatever reason, to be larger than the average. What determines that? Well, the situation, right? This is just an example. There are some other operators that we start throwing in the mix here, and we've seen some of these in action already and haven't really talked about them too heavily. But there's these two, which is in or not in, right? And those are always placed in the where clause. So in other words, we're looking for a piece of information that is in a set of data, or the negation of that thought, or the opposite, which is not in, right? So take a look at the little example here, right? So select customer name from customers where the customer number is not in the distinct customer number from orders. So we're excluding a particular customer from the orders table. So what kind of customer would this be? And think about it. If the customer number is not in orders, we're looking for the customers that we have that haven't placed an order. That's what this is saying. Why would you want that info? They'd be a great target audience for advertising, right? It's like, hey, place an order today. If you know which people aren't ordering, those are great targets for, pulling them out of your database and then targeting them for an ad campaign, for example. So that's why that might be used. So they go through that. Another possibility here, and this is where it gets a little bit weird, is to place that subquery instead of in a where statement, right? We place it in the from statement. So think about that. What goes in the from statement? which table the information is coming from. So for example, take a look at what they're doing here. So they're looking to select the max, the min, and the average, basically, of certain items. Where are they selecting it from? They're selecting it based on the order number from the orders detail tables, and then we're grouping it as line items. So this is going to find very specific information so that we can run these functions, right? So we just learned about these functions, and these are real common ones: max, min, and average, and sum, very, very commonly used. Can anybody explain to me what they think the floor function is? All right. So you'll hear this reiterated in the Python class, Python people, right? Whenever we talk about the floor, you guys remember this thing called modulus, where we do division and then we get a remainder, right? Floor division and really floor rounding is where you get rid of the decimal points and you're just looking for the whole number. So if I came up with an answer that was like 3.75, I would just throw away the 0.75 and I'd go with the 3. That's the floor. It's kind of like sort of like rounding, but you don't care about the minutia or the fractional portions. You're only caring about the primary number of that. Why would you care in this situation the primary number? Okay, what's the max number of items somebody is ordering? What's the minimum number of items somebody is ordering? What's the average number of items? Well, you can't order 3/4 of an item, so we just go with the smaller part of that, right? So if my average came out to 3.75, well, I'm ordering 3 items. Yeah, it's a little closer to 4, but it wasn't 4. I definitely ordered 3. Do you see the why? Right. So that's a weird little scenario. But going back to the larger detail here, is they're selecting a whole bunch of stuff out of this table, and then they're aliasing it as an output so that we can see all the line items, and then it can give us the results that we're looking for. So it's kind of like clever structuring, right? And notice the floor is used to remove decimal places from the average value of items. Okay. I don't know if I explained it as well. All right. Okay, so let's talk about what they call a correlated subquery now. And it says, okay, in previous examples, you notice that a subquery is independent, means that you can execute the subquery as a standalone query, right? So for example, you can see like basically this portion of the query. This is what they're referring to if you're missing it. I can just drop that into MySQL and hey, run it, and there it runs, right? Because it does pull information. But a correlated subquery that uses data from the other query, in other words, it depends on the outer query in order to actually have value, right? Because it's going to the outer query and we're doing a maximum and an average, and they need to work together. So even though we can run the internal one separately, the outer one will not operate without the internal one. That's what the correlated means. And I hope I'm explaining it somewhat well. Here's another example, right? We're looking here at a query, once again, that would operate all on its own. But in this case, the averaging happens inside the subquery as opposed to the outer query. And once again, the inner query would operate on its own, but would the outer query operate without it? Now, this one takes a little bit deeper thinking. And what they're trying to explain here is that they are codependent, right? Now, what drives that, once again, is situational, real frankly. And notice what it says here. It says, unlike a regular subquery, you cannot execute a correlated subquery independently like this. So in other words, I can't run this without the outer structure, And so that's how, when you know they're correlated or not. And I'm not super worried about that definition. You know, if you guys are worried about it for like a quiz or whatever. However, we have these other keywords, and these are ones that I have linked up from W3. So I have links to exists and any and all. And the first one we're looking at is exists, right? So I'm not going to bounce back to W3 to talk about that one. I'm just going to talk about it here. But this is a really weird one because here is where we take Boolean information, right? And what is Boolean, right? So I make this naive assumption, but I always forget that you may not have been exposed to that concept yet, right? So, like if you're in the Python class, you've heard a little bit about this, but we haven't really used it a lot. If you've done other programming, you certainly have heard of it. But a Boolean is a way to say a true false value. The only two possible values are true or false. That type of information becomes really critical in making decisions on information and which path you're going to follow with that information. So, for example, this query below would only operate if this statement executes to true. So, in other words, when we do an exist statement, the subquery would return true and allow the outer query to operate, but only if true. And then sometimes you have to do the reverse logic, right? Where you want the outer query to only operate when it's not existing or it's not true, right? And they're making the grander point here that those two terms, right, exists or not exists, are often used in correlated subqueries um, because of the logic that goes with them. All right. So let's just take a look at this little example. It says the following query finds sales orders whose total values are greater than 60,000, right? So they're pulling the order number, they're taking all the products and all the stuff ordered, right? And they're summing it. And they're getting that from the order details table. And now check it out, they're doing an inner join and they're joining on the order number and we're grouping it. Now we're checking to see, right, if that sum is greater than 60,000, right? And here's my question for you. Is this a subquery? Now, if your brain is saying yes, I'm going to make you question yourself a little bit. Having is also kind of another way to say where. And often you can use those terms interchangeably. And but what the kind of the convention is when we're qualifying things, having is kind of done at the end of it in terms of another condition to check. Right. Now, take a look at the alteration of that above thing. And this is where it gets a little weird. Now we're going to take that query that determines if the order that we're pulling is greater than 60,000. So basically, we're ignoring all the ones that aren't. And so if the order comes back as greater than 60,000, and we find like all of this work that happens here is just to look for orders that are greater than 60,000. If one exists, this becomes true. And then this query can operate and it will then find that customer and that customer name, but only if they're getting above at that $60,000 level, right? We're only pulling it when this is true. Now, this is a little bit more complex, right? There's a lot more going on here. And when we do our homework later, we'll get, roughly to this level, and we don't really kind of go that much deeper than it. And a lot of it is conceptual, right? I think our example does not have an inner join in it, but the concept is still basically the same. So exist qualifies whether or not the condition is true. If I wanted to negate that concept, right, and I would say not exists, right, then I would take the converse result set, right? It's just negating it. Um, I'm always really careful with those though, because a lot of times people's brains don't like to think in negatives or reversals of like information. So I get it if that feels a little weird. All right. So the general summary here is a subquery is nested within another query, or what we call the outer query. So inner query, outer query, main query, subquery, or query, subquery, however you want to like use the terminology is fine. Um, if you're using something that's correlated, meaning that the data is connected together somehow, um, the subquery data does depend on the outer query. They depend on each other to work, and without it will not. Right. What drives that? Logic, basically the logic of the data and the logic of the information that you're trying to extract from the data. All right. So I'm just going to switch really quickly over to W3Schools here, just to show you that, you know, they show, for example, they start with like the having clause, right? And just to kind of show you like this is sort of like doing a subquery, right? Um, I mean, it's not exactly, because there's no select statement, there's no from statement. The difference with a having statement is it's pulling it from the same table necessarily, right? When you look at the exists statement, um, and notice I like the way they explain this, which is why I'm pointing it out. It says the exists operator is used to test for the existence of any record in a subquery. So if I run a query inside of a query and it pulls back a result, that's the check for truth, right? Is it there or is it not? And notice the syntax difference, and then compare that to the information that we were just looking at the MySQL tutorial website, right? And this one's done in generic form. What's nice about the subquery is that it's a fully formed query. So it's easier to put together. All right. So they go through and they do a couple of examples here too. And somewhere I think they do, okay, they don't even show the not exist, by the way. They don't even demonstrate it. So whatever, right? You have to, it's a little bit situational. A couple more operators that our textbook talks about are any and all, right? So these are also related to subqueries, but notice the definition here. It says the any and all operators allow you to perform a comparison between a single column value and a range of other values, right? Like the exists, the any operator returns a Boolean value as a result. So returns true if any of the subquery values meet the condition. So you see like how that is a little bit different than exists. So I might be looking at 100 pieces of information. All I need is, do any of these match? You know, is really kind of the way to think of it. And if any of them match, it will return a true. Right. Right. So if you look at the syntax here, and this is a little bit different than some of the examples that we were looking at, where we were looking at greater than or less than or equal to, right? And this is the distinction our book is making on this. And, you know, any basically includes anything that works. There's also the all operator, right? And let's look at the difference on this one. It says returns a Boolean value, returns true if all of the subquery values meet the condition. So a lot less likely in most scenarios, but maybe, for example, I'm doing a subquery of all my students and like all of them need to pass. Otherwise, the whole class fails. No, we're kidding, right? That's not how it works here at school. But man, how would you feel about that, right? Like if your A grade depended on everybody else getting an A grade, yeah. But that's the distinction here. So once again, what drives the need for this? The situation and the logic of the situation. But this is how you would employ it. You just basically indicate it here. I do want you to notice in both of these any and alls that there's still an operator in play here, right? So for example, where, I don't know, purchase amount is greater than anything in the table, or the purchase amount is greater than all the things in the table, for example, or customer name, whatever. So those are the brief little examples I have on that. I'm now going to switch over to the author's PowerPoint here, and I'm going to hit a couple of slides. I'm not going to hit too many, by the way. I'm not liking the way the PowerPoints kind of flow from the book. I think I've said this before. I'm still using the book, but just take it with a grain of salt, basically. The general point, once again, here is to worry about subqueries. There is a little bit of kind of, I think, review that you have to do in terms of understanding all your basic query statements, right? And so they go back to where, having, from, select, and all that. So you need to know that stuff really well before you can delve into this. They also go through the process of describing a correlated subquery and a non-correlated subquery. And then have this thing where they say the use of common table expressions, and that part of it I'm not quite as worried about. But let's just kind of talk about this. Let's just move on from that. So we have 4 places that we can actually place subqueries, which I think is kind of interesting, in a where clause. And I think that's probably the most common approach, generally speaking. It can also come inside of a having clause if necessary. In the from clause, when we're trying to figure out which table, and then in the select, if we're trying to work with which columns. So this is, highly conditional. Once again, I say that probably the most common approach is to see it in the where clause. And that's what they're indicating here. So you have like a standard looking query inside the where clause. We have a condition we're trying to figure out. And in this case, looking for an invoice total that's greater than the average invoice total from the invoices table. That's the condition. And it's just easier to express it as a combined statement. Like the example I used before, rather than do a calculation, figure out what that amount is, and then hard code that amount in here when the data is apt to change, right? The beauty of a subquery like this, it's dynamic. So every time I run it, if there's more invoices that came in, those numbers would change, right? And the results would also change related to it, right? So that's kind of my general, tip on this. Now, they're going to do a lot in the book, and for those of you that took the time to read the chapter, you probably ran into this material where they kind of do this example where you could write the query like this, or you could write the query with a join. So you could do a join and join the 2 tables, pick out the joining field, and then focus in on the piece of data that you need and just make it part of one standard query with a join. So we're doing typically an inner join or to do this, and that is an approach that you can use. Which is better? Subjective, right? So here's the same query now with a subquery placed into the where statement, right? So this query is the same as this one. And this is what I was trying to allude to before. Okay, so why do we do this? Well, for one reason is that we're pulling information from 2 different tables here, right? The highlighted yellow is coming from the vendors table. The main or outer query is pulling stuff from the invoices table. In the join approach, we're pulling the information we need. We're telling MySQL how the tables are joined together. Like, what's the connecting piece? Well, the vendor IDs are connecting pieces, right? In the subquery, we're approaching it a different way, but we are still pulling information from 2 different tables. Which is better? Well, it depends on what you're shooting for, right? So, right, if they're both giving you the same results, because really what ultimately we're looking for is vendors in the state of California, right? If you're analyzing this, does it matter which pathway you take to get there? Kind of an interesting thing. All right. Um, all right. So the author does point this out, and I think this is actually pretty helpful, right? Why are joins better? Well, a join can include columns from both tables. Okay. Yep, it sure can. A join is more intuitive when it uses an existing relationship. So if you're joining tables on vendor IDs and that exists in both tables, heck, it makes sense to link them together like that. I get it, right? The advantage of a subquery, it can pass an aggregate value to the main query. So in other words, it can do a calculation or run a function or check a condition on its own and then send that back to the main query to be used as a condition inside of that query, right? That's one of the better reasons to, kind of to support that. A subquery is more intuitive when it uses an ad hoc relationship. So if it's not linked up on vendor ID, doesn't mean I can't pull the information from both tables if they're not formally joined with like a foreign key, for example. And I would agree with that last statement too. That long complex queries are easier to code using subqueries. So those are kind of like the primary advantages of this for sure. Now, I'm not going to dig any farther than this into this PowerPoint because I've talked about all the topics that I want to hit upon, but I thought that this is a really useful slide. And I think they did a nice job here of comparing a join to a subquery, both yielding the same results. I think it would be a really interesting question to ask somebody who works with databases professionally and that's like their only gig, like which one they would prefer. And I have my suspicions as to what they would prefer because I think like if they were doing stuff like this, these are queries that they have canned and they probably have forms built around them and they run all the time. Where if somebody's calling for something on the fly, the subquery is probably the tool. I would suspect that would be the answer. All right, folks, here's what we're going to do. We are going to end this recording here. So this is the end of the lecture stuff for the night. And I just have to find the little stop record button. And this video ends here.